One thing that's really important in today's architecture is organizing memory efficiently, because like I said, accessing memory hurts an algorithm. So we have this thing called a cache in a modern day architecture. Have you guys studied caches in your architecture? Okay, good. So you guys know. So what's the idea with a cache? The idea with a cache is you're going to take a whole bunch of data and bring it close in some sense to the core or to the processor so that you can process it more efficiently. You're going to bring it in batches, process it a lot, and then write something out. So you're going to get a lower cost. So each one of the cores in your architecture has its own little cache that it can get to really fast to do its algorithm efficiently. Now, that kind of makes sense at a high level. But I have this, is everybody good with that? Because I have this great analogy that I thought of one night that I might just tell you anyway because I kind of liked it. So imagine that you're a baker in a bakery, and you own your own bakery, and you make peach pie, and it's great because you live in a peach orchard. Right? So your peach orchard is right outside. And one day you get an order for 100 pies. And to do 100 pies, you need 1,000 peaches to put into your pie. So here's the question for you. Are you going to go out and individually go get a peach from your orchard, come back, clean it, peel it, slice it, put it in the bowl, pit it, whatever you have to do? Are you going to run back and forth and get each peach one at a time from your orchard? And the answer is, of course, no. You're going to take a big bucket, you're going to go get a bunch of peaches, you're going to bring them in, process them, and then you're going to go get the next bucket. And that's all that a cache does. It brings in a bunch of things at a time so you can process them, slice them, whatever, and then it goes and gets the next batch. So the assumption there is that whatever I get a lot of, I'm going to do a lot with over and over again to that same batch of things, peaches in this case. So that's basically the idea with caching. So how are caches used in practice? Did anybody have linear algebra? People have taken linear algebra. So matrix multiplication, for example. And and it's not complicated. So you can look at the picture, look at the math. I mean, basically, you have two matrices A and B, and the way you compute the answer C, you take a row of A and a column of B, and then you multiply each element, and then you add them up, and that's how you get the corresponding element of C. Very simple. So don't worry about the math, just look at the picture. So the key about this algorithm is you can imagine, and there are other algorithms that do this, you can arrange this matrix into blocks, and those are your peaches. You're going to bring in a block, and you're going to process it over and over again. You're going to get a partial result, put that in memory, and then you can bring the next block in. So this type of matrix, these types of linear algebra algorithms, we call them dense because it's very easy to process them in blocks. You bring them into memory, your cache, process them fast, and you go get the next thing from cache. So they're very nice algorithms for a caching architecture. And they have what the term we use to refer to that is locality. Locality in space and time. The elements in the matrix are close together, and I'm going to reuse them quite a few times before I'm done with them.